So today, lesson 5AA, it's because I'm squeezing it in between 5A and 6A, we'll be determining an equation for a proportional relationship where the numbers are a little more difficult to see, okay? So regardless of that, we're still dealing with the same thing. We're looking for some kind of a constant multiplier here, that we multiply the values on the left of our table to make the numbers on the right, and whatever that is, that happens to be our constant of proportionality. And then, of course, that helps us figure out what the equation is. For pretty much all of us, as long as the multiplier is a whole number, that's pretty easy. Even when the fractional values are not too difficult, like this one, it's not that bad. So the constant of proportionality is 1/3 in this one. And that leads us to the proportional equation that is C equals 1/3 P. Okay? But what are we going to do if we have a problem like number 1? Now, if I were to ask you, when I asked this last period, some people can just see what the multiplier is. So I'm just curious. Anybody know what the multiplier would be in this particular problem? And see, that just proves my point right there. By the way, what is it? Okay, but what are you going to do when you don't see it? Okay? So I'm going to show you 2 different ways. And by the way, we have talked about these ways. And what I said was, if you don't know what this value is right here, then work backwards. If you don't know or you can't see what you multiply 2 by to make 5, then working backwards means take 5 and divide it by 2. In other words, that means 5 divided by 2. And somewhere in your notes where you have room, you should write this down. And so, 5 divided by 2, doing long division, 2 goes into 5 2 times. And now we've run out of numbers, so this is where we would add a decimal, and this is coming straight from 5th and 6th grade. That now enables you to add a 0 at the end and bring it down. And 2 goes into 10 5 times, and we have a remainder of 0. And so there is the multiplier right there. Okay, now, we don't have to just use the 2 and the 5. We could also use the 10 and the 4. So watch. 10 over 4 equals 10 divided by 4. And whether you trust me or not, the division will come out to be 2.5 because 4 goes into 10 twice. Subtract, we've run out of numbers, so we do this kind of thing again. 4 goes into 25 times, and look, it's still going to be 2.5 all the way down. So what that means is that our multiplier in this, let me make a little bit of room here, is 2.5. 2 times 2.5 is 5. 4 times 2.5 is 10. 6 times 2.5 is 15. 8 times 2.5 is 20. And then I'm doing 0 last because it was not very clear what it was until now. 0 times 2.5 is 2.5. Now, this, to me, this will work on every single problem, but if long division is not your thing, then I'm going to show you what I think is an easier way of doing this. And by the way, you could have done that with this. 15 over 6 is 2.5, and 20 over 8, or 20 divided by 8 is also 2.5. Okay? All right, so we're doing this first with a decimal value. So the constant of proportionality is 2.5, and I ascertain that the proportional equation would then be y equals 2.5x. Now let's do number 1 again, but this time by finding the multiplier as a fractional value. So watch what I'm talking about. We're still trying to figure out what times 2 is equal to 5. So I'm going to work backwards. But instead, I'm going to stop right there as long as the fraction is reduced. Now, reducing a fraction is totally different than writing it as a mixed number. I'm not talking about writing it as a mixed number. I'm just asking you, is 5 over 2 reduced? Yes or no? It's not? Really? Tell me what goes into 5 and 2. Anything other than 1? Yes or no?
No.
No, I mean, so 5 over 2 is reduced. So what that means is that is the multiplier. The multiplier is 5 halves. And so the equation would be y equals 5 halves x. And once again, that comes from the fact that this over that is 5 halves. This, 10 over 4, reduces to 5 halves. This over this, 15 over 6, reduces to 5 halves. And this over this, 20 over 8, reduces to 5 halves. Okay? Let's go ahead and turn the page. So I want you to give number 2 a shot based upon what we just talked about. All right, so let's take a look at number 2. Here's our table in number 2. I'm going to do it as a decimal and then as a fraction. And I walked around to make sure at least a few of you did it both ways. So let's go with the decimal route. Who did it the decimal way? What'd you get? 1.25. How did you get 1.25? Yeah, remember, so regardless of whether you do it the fraction way or the decimal way, it's still going to be 10 divided by 8, okay? Starts like this, which means this, and then 10 divided by 8. 8 goes into 10 once. We've got a remainder, but remember, we don't do remainders anymore. So add a decimal. That allows us to now bring down a 0. 8 goes into 2 times, or 22 times, 2 times 8 is 16. Bring down another 0. And 8 goes into 45 times. And finally, the remainder is 0. So that gives us our multiplier. And 15 divided by 12 is also 1.25, and so on all the way down. Okay? So that means our constant of proportionality is 1.25, and I established that the proportional equation is y equals 1.25x. Now, as a fraction, I'm going to do the same thing because some of you did it as a fraction instead. But it kind of works the same way. So 10 over 8 will reduce. By the way, what does 10 over 8 reduce to for those of you who did it the fraction way? 10 over 8? Oh, you're saying reduce top and bottom by 2. Okay. What I meant was, what is it? It equals 5 over 4. Really, very good. So that would be 5 over 4 right there. And by the way, 15 over 12 also reduces to 5 over 4 by dividing top and bottom by 3. So it does not matter. Okay? So that was the same table going with the decimal route for the constant of proportionality or the fraction route. Your choice. So I conclude that the proportional equation is y equals 5/4 x. All right, so now number 3, your choice. Go ahead and do number 3 all the way through, please. All right, let's take a look at number 3. Now, if you went the decimal route, 3 divided by 4, 4 does not go into 3. It's too big. 4 does go into 30, however, 7 times. Subtract, bring down a 0, and then 5 times. And so if you went the decimal route, that would be the constant multiplier. But look, sometimes you luck out going the fraction route because watch, it's 3 over 4. And by the way, it's always y divided by x. Is 3/4 reduced? Yes or no? It's not? Sure it is, right? So look it, sometimes you luck out. It's already reduced. There's the multiplier. You have to admit, that's much, much easier than using 0.75, even though 0.75 is also a constant multiplier, okay? So, the constant of proportionality would either be 3/4 or 0.75, depending on whether you went the decimal route or the fractional route. And the proportional equation, I postulate the proportional equation is either y equals 3/4 x, or y equals 0.75x, depending on which route that you want. All right, go ahead and turn the page. Now, number 4 is really the same idea, except I'm squishing the x and y numbers together, and I'm showing you that that's really how you're finding them, is y number divided by x number. All right, go ahead and try number 4. Oh, 6/16 is how we can start this. But 6/16, if we divide both top and bottom by 2, that is 3/8. And so that means our constant of proportionality is... All right, number 5. We've got the number of cups of flour compared to the number of cups of sugar. By the way, what is the constant of proportionality in this one? What is it? Okay, you did it as a decimal, 1.75. How about as a fraction? 7/4. Just out of curiosity, how many of you did the fraction way? How many of you did the decimal way? Doesn't matter. Doesn't matter. No, as long as they represent the same idea. 7/4 is equivalent to 1.75, so it does not matter. So y over x, I'm going to stick with the fraction way because that to me is easier. And you have to pay attention. This is the y number. This is the x number. That's why it's 14/8. But we can simplify that because 2 goes into both of those numbers evenly. So that means the constant of proportionality is 7/4. And I postulate the proportional equation is y equals 7/4 x or y equals 1.75x. All right, go ahead and try number 6, please. All right, so there's one slight difference to number 6. We're talking about money here. So in this one, we're not allowed to leave it as a fraction. In this one, because you've got money, you need to figure out what it is as a decimal. Hello? It's okay? Yep. Bye. Okay, so once again, because we have money here, we've got to do the division to refresh your memory, even though you've gotten one of these in the homework every single day. We've got to move the decimal once to the right. There's not a decimal in the 15. There is, we just don't write it, and that means it starts here. We have to also move this, which means we put a 0 here. And when we did this on the second day of school, I recommended that you rewrite it because this number is now 5, and this number is now 150. 5 goes into 15 3 times. Subtract. Bring down the 0. 5 goes into 0 0 times. And so it is 30. Because this times 30 is that. This times 30 is that. This times 30 is that. Okay? So you might wonder, well, other than the fact that we've got money here, why can't we leave a decimal in there? The reason is because you would have a fraction mixed in with a decimal. And that's like having a fraction that is not reduced. And we can't do that in mathematics. So you may not leave a decimal within a fraction that is technically a fraction that is not simplified. And so since the multiplier is 30, I determined that the proportional equation is y equals 30x.